differentiation of logarithmic function. So we have the derivative of ln x is equals to 1 divided by x. If there is a function inside the ln parenthesis, like the derivative of ln of f of x, so first of all, you have 1 divided by that function first, and then you take the derivative of that function. So basically, you can draw a long fraction bar, put that function in the denominator, and then put the derivative of that function on top. So you don't have to write a 1 and then times a derivative and then start another line for just putting the derivative to the top. And then the last one, you don't see this very often. This is the derivative of common logarithm, log base b of x. So that is still 1 divided by x, but you have to multiply ln the base. So this one, the log, you don't see that very often, but it is good to know that there is the derivative for the common logarithm log. Okay, so I prepared 3 functions for you. Let's get started. So the first one is clearly a quotient rule. So we have the first derivative. So quotient rule, we always square the denominator. So let's draw a long fraction bar. And then I will square the denominator. And then this is e to the 6x. And then the top, that is the denominator, e to the 6x, times derivative of the numerator. So the 3 is there, right? And then the derivative of ln is 1 over x. And then minus the numerator, and then times the derivative of the denominator. So e to the anything is e to the anything. And then you take the derivative of 6x, so that is equals to 6, and this 6 is by a chain rule. All right, I think that's it. So now let's put everything together. You have f prime of x, so this is equals to 3e and then to the 6x divided by x, and then minus 6 times 3 is 18, e to the 6x, and then times ln x divided by, and then the denominator, you have e to the 6x times e to the 6, so that will be a 6x plus 6x, which is e to the 12x. And then this is your final answer. I know there is a fraction in the numerator. If you are doing works on paper, this is totally acceptable, especially in my class. If you are doing homeworks online and they do not accept complex fraction means you have one fraction inside another fraction, you can simply multiply the top and bottom by x. So when you distribute the x to each term on top, that will get rid of the first x in the denominator. All right. Moving on to the second function. So the second function, we have this. We have f of x equals to a big square root, and then ln negative 4x to the 5th plus 6x e to the 3x, and then close parentheses. So that is the same thing as a half power, right? So we have f of x equals to the entire ln raised to the half power. So ln negative 4 minus 4x to the 5th plus 6x e to the 3x. Now, let me ask you a question. Can I bring the 1/2 to the front using power rule? Can I bring this 1/2 to the front? Yes or no? The answer is no. So let me show you a quick example. So let's say you have ln 3 square, right? So that is equals to 2, bring the 2 down, times ln 3. This is approximately equals to 2.197. If you have ln 3 and then you square bracket square the whole thing, then this is approximately equals to 1.207. Approximately equal to 1.207. They are not the same at all. So that means if for the first line, you square the x first and then you take the ln. The second line, ln first and then square. Once again, the first line, square first and then you take the ln. Second line, ln first and then you square. They are not the same. Okay, so therefore, in this function, there is no way to bring the 1/2 down. So you have to start derivative at this point. Okay, the first derivative, this orange, right? So the first derivative, using simple power rule, you bring the 1/2 down, and then whatever is inside raised to negative 1/2, and then you have to take the derivative of that as well. So this might not have enough space, so let's try. So we have ln negative 4x to the 5th, and then plus plus 6x e to the 3x, and then close square bracket. So this one ln negative 4x to the fifth, and then plus 6x e to the 3x, close parenthesis, close square bracket. All right, and then you have f prime of x, so that is equals to, copy this one more time, fifth plus 6x e to the 3x, and then raised to negative 1/2, and then the derivative of ln, right? So you bring the entire function to the denominator, negative 4x to the fifth, and then plus 6x e to the 3x. And then what else? And then you have to take the derivative of the denominator. So this one, when you take the derivative, the negative 4x to the fifth, so that equals to a negative 20x to the fourth, but the 6x e to the 3x, that one is a product rule, right? So that one, if you don't mind, I will just do it right over here, so I don't need to squeeze that to that one little space. So 6x e to the 3x, and then we do this. So this is a product rule. Product rule is fg prime plus gf prime, so that is equals to 6x and then e to the 3x times 3, and then plus g, that is e to the 3x, the derivative is a 6. So overall you have 18 x e to the 3x, and then plus 6 e to the 3x. So therefore you have f prime of x equals to 1/2. How about this? We have a 2 square root ln negative 4x to the fifth plus 6x e to the 2x, close parenthesis, and then we multiply negative 4x to the fifth plus 6x e to the 3x, and then negative 20x to the fourth, and then plus, is that plus? Hold on. Yep, you add the whole product rule. So plus 18x e to the 3x, and then plus 6 e to the 3x. Wow. That is a big piece of work. Okay. All right. Got it. Okay, let's move on to the last one. So the last one, I have the functions right over here. You can write this down. So let me switch to another color. Let's use blue. Okay, done. Alrighty. So we have f of x equals to e to the negative 8x to the third plus 6x squared times ln x. So I can see a product rule right here. So the product rule is fg prime plus gf prime. Okay, let's get started. So we have f prime of x. So this one g prime. So you have a 1 over x, right? So that's what the ln. And then e to the negative 8x to the third plus 6x squared, and then plus gf prime. So that will be ln. And then e to the anything is e to the anything, right? Negative 8x to the third plus 6x squared. But in front of the e, you have a chain rule right over here, which is the derivative of the exponent. So that becomes a negative 24x squared, and then plus 12x. So this one, I don't see a way to simplify this, so I will just take this as my final answer. We have x, and then an e on top. And then what else? Wow, this one is one piece of mess. Okay, I will just start with the parenthesis. Plus 12x, and then times ln x. I would do this to not confuse you. Negative 8x to the third plus 6x squared. So that's it. The last line is your final answer. So am I being helpful? Like it. Share the video for me. Click the subscribe button before you leave. I will see you all in the next lesson. Signing off.